Okay, so we'll reread this. This just kind of, I tucked it in at the end of the last video. As usual, if I'm kind of rushed, it didn't go so well. So it's a small concept, but we are going to try and have some homework along the way. And we do have, economies and diseconomies of scale. It's a very basic concept that we are supposed to know. But economies and diseconomies of scale, it's a simple definition they give here. As a firm grows larger and produces more output, does it become relatively cheaper or more expensive to produce? That is, if the firm decides to produce more output, will the average cost go up or down? At a given production level Q, quantity Q, we say that the firm exhibits economies of scale if a marginal increase in Q decreases the firm's average cost. Yeah, so we have average cost, the derivative of that with respect to quantity, respect to Q, is the change in average cost with respect to Q. These things should not be hard, but we do admit that it can be difficult to interpret right. At a given production level Q, we say the firm exhibits economies of scale if a marginal increase in Q decreases the firm's average cost. I guess what they're saying is the derivative, that thing right there, is less than zero. So it's always kind of both in math. We should understand, but as a backup plan, we could simply memorize the definition. Yeah, so this right here is literally the definition of economies of scale, where obviously this is the diseconomies of scale, and if the derivative with respect to Q of our average cost, which is a function of Q, less than zero, economies of scale, greater than zero, diseconomies of scale, and equals zero, does not exhibit economies nor diseconomies of scale. So I always interrupt myself there, but the firm, blah, 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 the firm exhibits diseconomies of scale if a marginal increase in Q raises the firm's average cost. Equals zero, the firm does not exhibit economies nor diseconomies of scale. So this graph kind of shows that it will be Q hat. To the left of that should be economies of scale. Basically, you see, they kind of define it a certain way, which annoys us a little bit, but then they define it a second way. It is correct if the marginal cost is above the average cost, we're at economies of scale. If the marginal cost is above the average, if the average cost is below the marginal cost, then we're at diseconomies of scale. So we want that Q hat, I think, when we're producing. To understand the larger picture is kind of, what does all this stuff mean? That is harder, but to memorize the characteristics is fairly easy. But figure 3.12, that would be this, figure 3.12, depicts the average cost and marginal cost of a firm. In the initial region, Q equals 0 to Q hat, average cost is declining as output is increased, hence the firm exhibits economies of scale. In the second region, Q hat onward, the opposite is true. In the example, average cost has a unique minimum point at Q hat. I don't think they describe it well enough. I'm just repeating myself. But to the left of Q hat, economies of scale. They don't even say it. But to the right of Q hat is diseconomies of scale. So if the average cost is lower than the marginal cost, then it's diseconomies of scale. In general, why would the average cost blah, blah, blah? So these are just real world examples here that might actually have some level of truth. We can definitely read through this if we want to. Okay, it takes a while for them to get into some of the important equations, but they will. So profit maximization. So far, we have learned how the firm can produce output quantity Q at the lowest possible cost, given the firm's technology F and input prices, wage, and rent. This allowed us to construct the cost function. We now ask, given this cost function, how much output Q will the firm choose to produce if the firm can sell each unit of output at price P? Okay, so we go bit by bit in many, many different videos. Yeah, there's going to be a lot of very small, important concepts in here, so it takes a little bit. Yeah, just step by step. Maximizing profits, first order condition. I think just about anybody in the world, even if you have a background in nothing, understands that profit equals revenue. We have kind of the two, what I call the two most fundamental things. First of all, we all know that profit, I guess profit is as a function of Q, quantity produced, but who cares? But profit is always going to equal revenue minus cost. It's just so obvious that profit equals the money we make minus the money we spend. So that's kind of one of the simplest fundamental things. Now, typically, revenue is also pretty easy to define. Yeah, it's kind of weird. They should just say it now, and they talk about it when we read through this, but they don't define it until later. So if we produce a certain amount and there's a price on that, yeah, the price times quantity is typically the revenue. So it's always annoying when you have two P's. You can try and do capital P and lowercase p, but it doesn't really work. Yeah. But if you have price times quantity minus the cost as a function of quantity, that should be a C, sorry. Yeah. So those are the two most fundamental. Number one, we know that price, I'm sorry, not price, we get mixed up. Profit is always going to be revenue minus cost, and typically revenue is going to be the price per unit times the number of units. Should be obvious what that is. Yeah, so those are the two most basic fundamentals ideas. It's all good news because the book actually gets way more complicated than that, but we have that. Yeah. Okay. So I think we'll probably start here in the next video. Let's just see. Maximizing profits, first order condition. And they define a lot of this stuff. Is there going to be like a second order condition? All the way down to the second order condition, yes.